The Autodesk Construction Cloud connects planners, engineers, contractors, and owners throughout the infrastructure project lifecycle in one common data environment as the workflow progresses from planning to design into construction and finally to operations. The Autodesk Construction Cloud acts as the centralized hub for data storage, coordination, and communication throughout the project. In this example, starting in the planning phase, a high-speed rail alignment and station are evaluated near an existing rail line. Various alternatives are developed and evaluated based on functionality and feasibility in their contextual environment. Restricted or environmentally sensitive areas are identified and delineated to aid in this analysis. Multiple alternatives are created and expanded within the same model. Owners and planners then utilize tools within InfraWorks to conduct passenger simulations as part of the purpose and need study. These simulations consider passenger volumes and schedules as well as constraints and restrictions. The design alternatives are stored and accessed within Autodesk Docs, where team members with appropriate access permissions view and interact with the model. In the design phase, existing conditions are collected prior to the start of detailed design. Using the Autodesk connector for ArcGIS, designers and engineers compile libraries of existing conditions data that are then easily added to their Civil 3D drawings to provide context for the project. Once this data has been assembled, teams share their CAD files and surfaces with other disciplines using the Design Collaboration module. These other disciplines then consume these shared files as references for their own design processes. In Civil 3D, detailed design is done efficiently with rail tools that create intelligent and dynamic turnouts and crossovers. Alignments are linked to profile data and other parameters. Rail assemblies are utilized to build a detailed corridor model. Designers and engineers then harness design automation using Dynamo for Civil 3D to add additional elements, including plinths and electrical systems, creating a complete rail transit model. Dynamo for Civil 3D is also used for design evaluations through the creation of a rail vehicle clearance envelope. Once the model is ready, engineers inspect their design for any issues using the tools provided in Civil 3D. Structural engineers utilize the corridor model to develop a bridge in InfraWorks. Here, they determine relevant bridge materials, dimensions, and critical parameters. This model is then imported into Revit for documentation of the bridge layout, sections, and details, including complete rebar detailing. Plan sheets can be set up and easily maintained in both Civil 3D and Revit as needed. When plan sheets are uploaded to the project, Autodesk Docs will scan the drawings to assign sheet numbers and titles based on the sheet content. Search tags are also added as needed. Sheets are then accessed and reviewed by the project team, both in the office and in the field. These sheets and files are used as reference documents during the design reviews. Reviewers add callouts, markups, and comments to communicate problems or issues. A reviewer sets the review status of each sheet and file and distributes the review summary to the entire team. As a project moves into the pre-construction phase, engineers and contractors coordinate the model details to include valuable metadata. In this example, they add pay item data to the corridor and extract a summary of quantities with ease. These same design files can be accessed in the Autodesk Docs viewer, where the extended metadata and property set information is displayed. Corridor models can then be imported from Civil 3D into Revit to serve as a context for additional design elements, like the transit station in this example. The Model Coordination module adds valuable insight to the constructability review process. Model views are set up as part of the interdisciplinary design coordination process, enabling the team to view an aggregated project model. Clash detection features allow engineers and contractors to review any potential conflicts prior to construction, thus helping to avoid costly rework and in-field conflicts. Issues are used to document clashes, assign to relevant stakeholders, and track their resolution, ensuring efficient communication across the project team. As the design files are updated, team members can compare versions to understand the impact of design changes. These features help to ensure that the entire project team is working with the latest design information. Using the Timeliner feature in Navisworks, the project schedule data can be imported and associated with model objects to create a 4D simulation. This assists the team in assessing construction feasibility and identifying potential conflicts in scheduling or phasing. The construction phase comprises field execution and closeout of any project issues. In the field, the contractor has access to current versions of plans and other files at all times. They create RFIs when needed to request additional project details from the design team. As part of the RFI, the contractor adds markups and comments on the plans and includes them in his or her request. The contractor also adds images from the field. The RFI is assigned to the field inspector, who adds further information to clarify the request. It is then assigned to the engineer of record, who reviews and responds to the RFI as appropriate. All actions associated with the RFI are tracked from its inception through closure and distribution. Given his or her project access, the contractor can also update the drawings with as-built information throughout the construction process. As changes are made in the field, this information is communicated back to the engineer, where field changes are accepted and documented, or further revisions are made. These changes are tracked as issues to ensure proper project closeout. In the final project phase, operations, the owner gains access to the complete set of documents as well as the aggregated model created during the previous phases. Asset data and property set details are now utilized to provide more information about specific project elements. The final project documents are also published to ArcGIS for future access, including the same metadata. Through the BIM 360 and ArcGIS connection, these project files are accessed and referenced to provide a complete digital twin model. The final model reflects the correct project geometry and associated metadata, both of which are used for asset maintenance and operations throughout the lifecycle of the asset. The Autodesk Construction Cloud helps connect your project team to ensure that you can efficiently manage project data and communications from early project planning through handover and operations.